Alrighty, welcome to the next video in the, well, I suppose this is the TF Future series rather than the TF History series, but this is the TF4060. I think that's the best way to say it. What do we got here? Well, we got ourselves a, on this guy we've got ourselves, this is the Rev 0, so this is the original prototype. So we have an FPGA on here, Lattice ICE40, an HX4K jobby, with an SPI ROM too. At boot time it reads its code from the SPI ROM and off it goes. CPLD for the bus translation, same as the TF40, so the 1260 and the 360. On this one we have up to 128 meg of RAM. On this one we've got pads under here. I'll show you that in a second, but I want to show you it working before we do that. We have a potential, we have an IDE interface, and I think pretty much that's it on the prototype. Now we'll take a look at this guy, the sort of, I don't know how to put it, yeah, this is the Rev 1. Again, recently built this guy, so it's new in. ICE40 again, 128 meg RAM. I'll pull it out and flip it over in a minute and show you underneath. A Raspberry Pi for programming. The whole of the programming interface can be done through the Raspberry Pi. You have the headers for the JTAG and for the SPI ROM, just the same headers as these guys. They are there. So this is SPI ROM header programmer that I've used before. This is the standard Xilinx JTAG pinout that I've been using since forever. But I've refactored both of them so that they also come out onto the hat for this Pi Zero. And this guy can simply program both of those in one hit, one after the other, obviously. This guy is up and running. I don't know what speeds we're getting at the moment. I think we're just at 50 megahertz, as usual. So it thinks it's a 44 megahertz clock at the moment. I'm not sure why it thinks that. It should be thinking we're higher than that. We can do a few AAIB type stuff, or AIBB stuff like that. I always get those guys confused. In the meantime, trying to think what else. So the modern parts, the new bits are refactored. This it's slightly wider so that there's standoffs. I believe that this one is wrong because Chucky gave me the wrong coordinates, but the rest of the standoff coordinates are okay. They will work. I put some holes through there so that at least you could zip tie. So these are holes that in the routing, so at least you can zip tie some kind of cooling solution on there if you want. I suppose I could give out the dimensions for that at some point. Yeah, that wasn't very impressive. So I think this guy has a lot to do yet. So IMU test. Yeah, that's better. Eclipse test. I think the speed to chip RAM is pretty bad at the moment. I mean, it's kind of I got it booting and we haven't really gone much further with it than that. But sort of math in the processor is pretty fast, I think. Am I going to be proved a liar? It's not super fast, to be honest, but yeah. Where's memtest? Memtest will give us a good indication of what's going on. I don't think I have burst up and running yet. So yeah, we're not there yet. So it's working, but it's not super fast yet. It needs tuned. So that's where we're at with it. Now, sort of a bit of trolling. So imagine this. So you imagine you're John Hurtle and you're working on the prototype. You've got one of three of these that exist in the whole world. You get the latest firmware from the asshole that made the card for you, and you turn it on and you get this. I have to say I spent far too long on this, and at some point I might show you guys how I did it. But that's in the in the accelerator card. It's not a modified ROM. So John flashed his accelerator card and he got this. So mostly it was a proof of concept that the ROM, that I could use the ROM and blah blah blah, all that sort of stuff. That the ROM, we could actually put some code in there. I did go as far as even getting the B to to work. But yeah, at some point, if anybody's interested, I could do a live stream on how I did that and how I got that working at some point, and then it switches to Amiga also, obviously. So yeah, let me pull this guy out for a second. So if you can get underneath it, there is, for all the people who go, oh, not got enough capacitors on there, it won't work. Every capacitor is coupled as tightly as possible to the power pins, and we've got another set of RAM chips on the bottom, and a fuse for the, is that a short? Maybe it's a short there. And a fuse for the Raspberry Pi. I accidentally put the Pi hat on backwards, so I had to solder the header on upside down because I'm an idiot. That's the support needed for the FPGA, so that's a 1.2, I think it's a 1.2 volt reg that's there, a linear reg just to give the core voltage for the FPGA. The FPGA runs absolutely freezing cold. There's no temperature in it at all, and everything else is kind of what you'd expect. And under here you've got the possibility of an well, you'd have to put on the buffers to get an IDE interface. And in this case, it makes sense to use a buffered IDE interface because you're going to want to put the drive somewhere else in the case, right? You're going to want to mount it somewhere or whatever. Not like in an Amiga 500 or an Amiga 1200. So, yeah, kind of like I think I still have the 3 diodes of doom. By the way, if you have 3 diodes like this, please take them off. If you get a 3.3 volt short, you will end up with a fire in your card. And I don't just mean in my card. If you have 3 diodes in series to ramp up to try and protect, in quotes, your 060, you aren't going to have that problem on an Amiga because I don't want to get too deep into it, but you have got enough chokes and things. You won't get enough surge current that the Amiga chipset voltage will rise above the supply voltage for the CPU. It just won't happen. I've done the maths, and I've done the maths like in absolute worst case conditions. And if you do end up accidentally shorting your 3.35 power supply, those will go on fire. So yeah, I've had a fire. That's how I know. So yeah, this isn't actually the one Gadget gave me. This isn't the one that Gadget repaired. That one that Gadget repaired is over there on the shelf. But yeah, so this is the TF4060. It's it's just not there yet. There's just a lot of tuning to do, and with the summer here and everything, it's been kind of difficult to find time. It's been kind of difficult to find the time to get to work on it. So yeah, I can't think of anything else. I mean, it's just been a kind of one of those projects that I just got on and did during lockdown, finished it, got a prototype built, gone on with these builds. I think for these guys, they will only be built by Chucky and Alan Marks, unless Super Duper wants to do them. He did tell me he didn't have an Amiga 4000 or an Amiga 3000, so that's the reason why I don't think he'll be picking up this one. Oh, and I haven't got a way of demoing it here, but DMA, I have been using one of these guys with a fast lane card. Let me just show you the fast lane card. I have been using one of those SCSI to SD adapters with a fast lane card, and that's been one of my standard test cases. It works, and it also works in the Amiga 3000, my Amiga 3000 over there on the shelf. So yeah, DMA works. So all of the things that Amiga 3000 users are going to be worried about, they do work. It just needs tuned and made reliable. That's really all we're at now. All right. Thank you for watching. If you like the video, give it a like and all that sort of stuff. Click subscribe and all that if you want to get notified of more content. Thank you for watching. Take care and have a good one.